All right, so before this starts, let's set expectations. This is pre-meeting number 2 from Applying the Scientific Method to the Geometry of the Earth, a panel hosted by Dr. Shiva back in November. This session is where Flat Earth presents a proposed experiment for discussion. Pre-meeting number 1 focused on the sun azimuth and elevation calculations. Now, what you're about to watch is not the experiment, it's not a debate, and it's not a verdict. This is the checkpoint. This is where methods get examined, assumptions surfaced, and uncertainty gets addressed before any claims are made afterwards. So in this session, Kevin walks us through an ILS-based measurement idea, not as proof or a magic bullet, but as a proposed test using real-world navigation infrastructure. We also introduce alternative approaches, not to win, but to stress test the thinking. Different methods, but the same standard. Now, because this isn't about what feels flat or looks stationary, it's about whether a claim survives contact with measurement, geometry, and error bars. No slogans, no vibes, no escape hatches. If an argument can't make it through this call, it won't survive the experiment. So to be clear, this isn't censorship, it's quality control. So let's roll the tape.
Oops, are you there? You have to unmute yourself. So let's, I think we want to wait. There's a guy, there's another, 2 people said that they were coming from the Flat Earth group. Let's see if they show up. So Heather said, can everyone do a sound check so they can hear?
Hello? This is Dan.
Yep. Dan.
Hi, this is Prabhakar.
Ryan?
Yeah, can you hear me? It's Ryan.
Kevin? You have to unmute. Can we? There you go. Oh, you get asked to unmute. Just unmute. Unmute, Kevin. Kevin, can you unmute? A pop-up will come up.
Yep. Sorry, guys. I need to join with my computer. That's my phone. That's crappy quality. I leave and join with my computer.
Okay, there you are. So that one, there's another one of you. Okay.
Yeah, you said he had to join with his computer.
Okay. Bobby B, who's this? Hello? Bobby B, who's that?
Yep.
Hello, Bobby B? Hi, Bobby B, who's that?
Hey, how's it going?
Hi, is this Globe Slayer?
That's me.
You're fading in and out.
I'm sorry, I'm driving. I wasn't really planning on doing this. I just kind of didn't know about it till the last second.
Oh, is this Globe Slayer? Hello?
Yeah.
Okay, good. All right, so we have 3 people from the Flat Earth team now, and we have 3 people from the Globe Earth team, as we decided to call. So the purpose of this, we're doing these, this is the pre-meeting, so we may end up only having 3 and 3, which is fine. That's okay. So what we want to do is, on November 8th, we're holding a summit, and we want to review the process of that summit. But what we decided was that we will likely have this summit over 2 weekends, on November 8th, and then on November, what is it? Is it the 15th? Which is the following Saturday. And we'll do it at the same time. And the reason is that we want to give people sufficient time to formulate their hypothesis, which may require them to go get experts to help. Some people have different mathematical skills. So we wanted, in fairness, to give everyone a chance. So what we did yesterday was we level set that one of the goals here is to make sure everyone follows the scientific method. We reviewed that, and I think Dr. Prabhakar drew a diagram out, which we'll share on the 8th. But the diagram, we can bring it up, goes through the process of how the summit will essentially run. There is two, and by the way, I think collegially, this is not a debate. This is, frankly, to all of us to work together to support one another. So we have something called an observation that takes place. Out of that observation, you develop, in the second step of the scientific method, a hypothesis, typically represented as a mathematical model. So we said, imagine someone sees an object being affected by object M being affected by a force. They may say, oh, the force on that object is equal to M times A squared. That's the model. So the key thing is the hypothesis is reflected in a mathematical model. Then you do experiments, and then you gather data on these three variables. And again, we're doing a simple example. F, M, and A. You organize the data. And if the results show the relation between F and MA is F equals MA, not F equals MA squared, then your hypothesis is wrong.
They're wrapping up the order.
If it's correct, your hypothesis on the far right
They're wrapping up the order.
is rejected if it doesn't match, or it's accepted. Okay. Evidence. I think you want to move that to the top. It's not the box on the bottom. Evidence, just to be clear, is reproducible predictions.
14 minutes.
So, by way of example, what we discussed was, you can move it right up to the top, Prabhakar. No, the word evidence. No. Just the word evidence. That box evidence should be deleted just under the scientific method. No, it shouldn't even be a box. Just put scientific method. Evidence equals reproducible predictions. So the point is, I come up with a way that I think the world operates. The world is round or flat. I look at an observation. I have a model. If that model is able to predict that observation, then you have evidence that the Earth is flat or the Earth is round, or force equals mass times acceleration. Okay? So that's what we discussed. And as a part of that, we said, okay, what is an observation that everyone so one of the goals is that anyone can do. What is an observation that anyone can easily see, whether you're someone in Africa, a child, 5-year-old, or an 80-year-old sophisticated scientist? And one framework was you look, I don't know if you guys can see, I'm looking out, I don't know if you guys can see here, but I'm looking out. I live on a top of a hill here. I'm looking out over Boston. The moon is up there. So I have huge picture windows, and on these, you can think about these picture windows as being a grid of 100 by 100. And if I were to look out here at 8 a.m. tomorrow, the sun is going to be in a certain location. Okay. If I have a model that wants to predict the location of the sun, the input to that model would be the date and time and my longitude and latitude. And I think Dr. Prabhakar, you proposed this a 5, right? We just gave a random formula, which would represent the model, okay? So, the X, Y, and Z are the variables into the model. And then that formula would be representing where the sun's location is. I mean, this is just a random function for the globe or the Earth. So each team would propose their model. They have to know mathematics, and some people, if they don't know mathematics, we're okay with that. They can go use tools. So that's why we decided we'd give people a week, so no one feels like they're handicapped. So a model would be developed to show where the Earth or the sun would be, and that's one experiment we can do. I think Kevin wanted to propose another experiment, which was, and we'll let Kevin describe that. So we could do two things. We could do one for the sun and one for something else. It would just take a little bit longer time, but on day one, on Tuesday, we could propose both, and then both team goes across, and they would have to come up with 2 formulations and then a measurement capability. So that way, no one feels like they're being forced to do one or the other. We do both. It just maybe we have to do over 3 weeks, but that's where we're at. So we thought we'd let Kevin propose his experiment today. Is that okay with everyone?
Mhm.
Mike, Dan,
Yeah, it'd be good.
Ryan?
Yes.
Yeah, sure.
Globe. Go ahead. So
Go
Kevin,
for
why don't you propose your experiment? I think you wanted to do something over water, right? Is Kevin there?
Yeah, wait, let me see if I can screen share.
Yeah. I think you have to let him screen share, Prabhakar. But whatever we do, it's always grounded in the scientific method. Go ahead, Kevin. I think you have to make him co-host, Prabhakar.
He should be able to share his screen now.
Yeah.
Recording stopped.
By the way, we
Yes.
didn't record
Yes,
for
yes.
privacy reasons, because it's not the summit. So I think for some reason auto recording, we stopped the recording because we don't want people feel inhibited in any way. Is that all right?
That's fine.
Okay. We will record and stream out. So go ahead, Kevin.
You can see this. You can see the screen,
Yeah,
Yes.
we can see it. Yep.
but now you see my text or my screen, my presentation.
We see a PowerPoint
Okay.
and it's on slide 1 with an airplane somewhere.
Okay. I was thinking what I will offer yesterday. I have 3 things, but I think this one is the most valuable for both sides. Because it has the ground included, it has radio waves, and it is over water. We have a radio wave expert on the Globe team, and it is decisive. It can be easily achieved. There's a definitive result, but it requires one thing. It requires a plane. I first thought maybe I do the string, but it's even more complicated. But if you have a plane, every plane uses radar signals from the ground to assist with the landing process to land on the runway. In the pilot's primary display, we see on the left here this square thing. And we can with this thing we can see how it's connected to a radar station, to the ILS system, and the ILS system is a radar thing which every big airport has. And this is this thing. It has two stations, two things which are leveled in different directions. One is leveled equally, one is leveled 3 degrees up, so that when the plane starts his landing process, it will receive those 2 signals. It will see how which signal is stronger. And so it's 3 degrees. The most airports are on 3 degrees. And so we can see here when it's the same power from the same signal,
Recording in progress.
then it will decrease on 3 degrees. And as I said yesterday, we can via sinus function, we can see a difference between globe and flat Earth. If we have a plane circling above water, we don't have convection currents in the way. It will land. But the main important part, what we want to look at, is we have one height where we circle, and then we see where at which distance here, the yellow, we will achieve the glide scope signal. So here is the prediction. we circle higher above the landing, the usual landing, and then when you are further away, you have a sinus function here. Flat, you would receive the signal at 23 miles, and with a little altitude from this ILS tower. And if we have a globe, it will be more to the ground here, this slant, this slope. You can use 8 inches per mile squared here, even up to 1,000 miles is accurate, and you would receive this glide scope signal in less time. And here at this 21.7 miles, and this 60 seconds difference. And yeah, you can repeat this a lot. You can circle with this with the plane, and every small Cessna can do it. You just need this radio altimeter or any instrument. You can rent those Cessnas for $200, $300. All you need is this little the primary flight display, and yeah, the slower the better, and you have decisive results. And for me, I think it's even better than the sun, but we can argue on Saturday because I have the ground related. I have with the sun, with the method is my problem that it's not directly connected to the ground, and so I would ascribe a false correlation fallacy to this, because even if we describe the sun, its path and predict it, we can still not argue the ground. And here we have the ILS tower on the ground, and it's well above the water, so any refraction claims are to the minimal, and yeah, we can see what's going on. And I would like to see this. I have two other ones, but I think
So can you go to slide 13, Kevin? I think this
yes,
is
this is the
yeah. So this is to me the experiment. Okay. So
exactly.
if we follow the scientific method, the globe people, Prabhakar, Dan, and you guys would first propose a mathematical formula, right?
Yep, I can
Or-
produce both formulas, predict.
Well,
Do the
yeah. So
formula
I'm
for
saying
flat
the
and for
globe
globe.
people would produce their formula, and then the flat Earth people would produce their formula. And then you do the experiment and see if the results match the formula. We apply the same process, right, Kevin? That's what you're saying.
Yes,
So
I'm fine with your method. Yes.
let me ask Prabhakar, Dan, and Mike, are you guys comfortable with this? I mean, you guys don't have to answer, but the process would be, as Dr. Prabhakar showed in that diagram, the globe people would say, okay, you have an object that's moving, right? Or a location, you have the curvature of the Earth, and then you would come up with a formula, I believe, for the hypotenuse there, really the hypotenuse,
Yeah.
right? So we should figure out what what are we should all agree what the inputs and outputs are. When I propose by the way, just as a side, and we can argue there is a ground thing, which is a human being who's on the ground. Okay. There is a reference point. Because but nonetheless, for this case, I think the input would be the location, I assume, of the plane, XYZ, and then you're calculating the output is that nautical miles, right? Is that what you're proposing, Kevin? You're predicting the nautical miles, because if the Earth is flat, then you would have a longer amount of nautical miles than if the Earth is round. Is that what you're saying?
Yes.
Okay, so if Mike, Prabhakar, and Dan, you guys are with this, you guys would have to go off and develop the equation of that hypotenuse. And Kevin, you, Bobby, and Ryan would have to develop the formula for the hypotenuse in the flat case. Is that what we're saying?
Yes. Yes, yes, you can do whatever you like. I tried great circle routes, everything, what you
No, no,
like.
but we should agree what the
the-
the common measure is, and we're saying it's at hypotenuse. Yes, Mike,
Yes,
Dan,
yes.
Parker, any thoughts?
I'm a little unclear what exactly is being measured here. It's the distance, and how is that distance being measured if that's what is being measured?
Yeah, so I think I think before we go to the Mike, I think the formula the model would have to calculate that distance, right? And then we can talk about the measurement. Let's take 2 steps, right? First step is each team would have to develop that mathematical framework for that hypotenuse. Does that make sense?
Yeah, but
You,
there's
I mean, I don't need you if you don't like to. I can propose different things, and you can just say
There's-
yes or no. I'm not like, but I know you want to do it equally, but
Well, I
I'm
think
not
I think
into
you have
math.
to have. I mean, I think to compare apples to apples, or
Yes, yes. I just say if you don't know the math, I won't blame you for it.
no,
I'm
and
not.
I understand the math, but there's quite a few different variables of that we need to kind of address to make sure that they're being accounted for before we get into making a model. Because if you're going to miss out on variables, then what we're going to end up having is a hypothesis that's very vague and isn't definitive. One side may have one hypothesis that's very definitive, one may not. So if one doesn't have one that's a very definitive, then it's kind of a moot point at that point, because there's at least 5 variables I can come up with looking at this right now that's going to create very much issues with how this is set up right now.
Still much less than the medium in between the sun, the material of the sun, all what I would count now for the sun. But yeah.
Do you have the equation for this prediction, the model for this
I have it written
situation?
down on my, I have the sine function and the
so what is the
I would
input
like
and
to
the
present
output?
it on Saturday. But you even
Oh,
start with the
Prabhakar, can you bring up
observation.
your? Well, no. What I'm saying is your equation. What is it relating? What are the input and output variables?
What is the dependent variable? What is the independent variable? And
the plane's distance is varying.
From which distance? So you have. Let's look at it this way.
the
You have,
ground distance.
yeah, you have so there's the distance. Prabhakar, can you bring up? If you can take a
From the tower.
screenshot of this,
The distance to the
Prabhakar.
tower is different, yeah.
So
Yeah, but there's 2 distances. One, which distance from the plane to the top of the ILS tower? Is that what you're saying?
Yeah, the altitude we keep the same for both predictions. This is the same. It's this is
Oh,
also
okay.
yeah.
So H
To
is
do-
the same, height is the same, and the hypo. So you set the height as the same, and the output is going to be the hypotenuse. So Prabhakar, it's H, or let's call H the hypotenuse here, is equal to some function of these variables. The height of the plane, the runway distance, and whatever, the curvature and all, whatever people want to formulate. That's up to them.
So here's some difficulties that are going to confuse that's going to create some issues with this one specifically. Even if we use a Cessna 172, is going to be one, obviously getting a Cessna 172 as well as an instrument rated pilot to begin with. The second thing we're going to need to do is that the difference that is calling out here is basically a mile and a quarter, or 1 nautical mile. A Cessna cruising
Right.
speed is roughly
Yep.
like 120 miles an hour. That's going to be a
Yes.
30-second
I
difference.
calculated this. It's 70 seconds difference. It's
Okay.
it's almost 70 seconds.
And what speed did you
Uh,
use for the Cessna? Did you use a stall speed or did you use a cruising speed?
100. I think this test was with 100 knots or something over 100, like a normal.
Okay, so
Cessna speed,
100
and the
knots is
difference
roughly 120 miles an hour, right?
It's and you have 60 seconds difference in those things in those distances. Yeah.
You have 30 seconds, not 60. 1 mile.
You can come up with your math next time. I'm sure it's
Okay,
60.
so-
It's more than 60, but and the instrument is in the Cessna. I don't know. I haven't understood your critique about the instrument.
So the instrument I have is going to be, what's the beam divergence of the antenna? What is the transmit power of the antenna? What is all these other things that we need to take into consideration if you're going to set up a radio link that needs to be taken into consideration for an end-to-end point location? And when we talk about this, you're saying that it's a 2 antennas stacked on with 3, with 3 degrees each. That's from the center point. So that's actually what, 6 degrees separation between each?
It's 3 degrees. It's both beams. This lower beam, this lower thing has 0 degrees, and the upper one has 6 degrees, and they both give out signals. And
Right.
the plate
What's the beam
interprets them
divergence
at
of the
3 degrees. So
antenna
it's
that's
3
going to
degrees.
separate the signal as it's transmitted out? Because that's going to
And,
tell you
I
what
need to,
distance you're going to be
address-
taking out. Because this isn't a laser, this isn't a string, this isn't a wire.
Right.
It goes out and is divergent from the antenna.
the interference.
There's multiple waves hitting these things and then coming back again. And so
It's over
that's one
water.
of the
What should
things.
reflect it? There's nothing to reflect it. It goes
It's
out in
bu-
2 different
radar
directions.
is being bounced back, right? That's
It's
how
not
you're
radar,
measuring
it's
the-
radio navigation. So it's single one way. So it's transmit from the,
Okay.
there's no receive at the airport, it's only transmit. But
I see.
but the issue is going to be, what's the beam divergence? And you have to take that into consideration to sit there and say, again, this is where the hypothesis is going to matter, because the beam divergence is rather large, and you're using it as, it's like basically like you're holding a string out, and thinking of line of sight means from the center of the antenna straight out. Your hypothesis from the get-go is going to be completely irrelevant, and we're going to have one hypothesis that's going to predict something and one that won't, because because variables aren't being attached to these to begin with.
Those multiplying of the things are just from of the beams. If they claim they can multiply, but then it's double the angle. It's we don't get into this range. It's not that.
Look, I'll shelve all my objections. I love this one. I think this will be great. I think that this is going to be perfectly right up my alley, and I think that a lot of people are going to struggle getting to a hypothesis to start with. But I'll
Okay.
leave it at that.
No, but I'm happy.
So Dan, do you think that you guys can come up with a hypothesis? You guys, a formula?
Oh, I don't have a problem with that. I think that's something that we can work out pretty easily. But
Okay. So the
I'm
bottom
concerned
line
about the
is,
other side. But that's not my
well,
problem.
that's their problem. So the globe earthers and the flat earthers, they're going to have to write the input, like Dr. Prabhakar said, independent variables, and then propose their model, right, Kevin? And so would the globe. And then you would go do the measurement and see if your data matched the results. Okay? Similar to what we said with the sun. In the sun case, you have the latitude, longitude of the individual who's on the ground, the location of the sun, in a 2D space, and then you have to, again, formulate that. So that's where we're at. So I mean,
I just want to interject one thing, and it's going to be like, we're talking about a plane. We're talking about a pilot maintaining an altitude specific
Right.
with, depending on air cover, atmospheric conditions and things like that. We're talking about radio wave modulation and propagation, which is going to be variables and everything else. Be far easier to use a theodolite at some point, because that's a scientifically precise instrument, as opposed to the individual skill sets of individual pilots and someone's math.
No, but you're way above water. Theodolite, you will only aim very low, and then it's the refraction.
Do you not think that still occurs at those things? I mean, there's a thing called tropoducting. There's temperature inversions. There's things like this that can change all those things with radio waves. I mean, we're talking about relative humidity. We're talking about temperature. We're talking about all these things need to be accounted for, which I don't believe you guys are accounting for. And it's going to make this a much more difficult thing, to where it's going to end up being for sake of another word, inconclusive, and therefore a win for flat Earth, as opposed to something very decisive. Just from my experience with radio that I have.
don't see a problem with the altitude. I don't see a problem at all with altitude. You can have then you have $100 more, you rent a better one. No problem with the
which
altitude.
goes faster, and you have less time to measure, the actual differences. But sure.
Yeah, we will see the seconds. It will be way,
I guess what I'm trying to say is,
way-
how do you measure this? The plane is just going to hover there?
No, it's going to do circles. So as it's coming into the airport, and
Oh, I
and
see.
and,
I
and,
see.
and Kevin,
See
correct me if
here.
I'm wrong, because I want to make sure I understand how you want to do this. Okay, but I want you to correct me to make sure I understand first. Okay. So as the plane is circling, as it's lining up for the airport, it has no signal. Then when it gets a signal, it's supposed to mark what the location is. I'm guessing by GPS. That'll tell you the exact distance from the transmitter, which we would have, I'm guessing, the GPS coordinates of. And depending on that distance, that's our distance over ground. Then we add and then we end up doing the Pythagorean theorem saying our altitude's this, our distance over ground is this. And now we have the flight path that goes through it. Correct?
Yes, sounds great. And we will circle and we'll do it, see it again and again.
Well, you're going to have multiple data points, right?
Yes,
As it's coming in.
yes.
You'll average those or something, right?
Yes.
Yes.
Yeah. I mean, yeah, you would have them circle. It's just until they get the signal. They don't actually have to land. But
Okay.
we're going to need Air Force would have, Air Force, excuse me. We're going to need an airport with ILS. We're going to need an instrument rated pilot. We're going to need a plane that has ILS on board and things like that. And on top of that, we're also going to need to account for multiple variables in atmospherics. Regardless of what Kevin says, there's still atmospherics that are going to complicate a radio wave propagation, because this is what I did in the Navy in the same sort of environment.
I have a pilot who's interested. I maybe can convince him. He's
Okay, that's one
interested,
pilot. And how are we going to accomplish this over multiple times? Because the idea was to do this multiple times over.
Yeah. Good.
I think the execution of this, Kevin, I think the mathematics, I believe each one of you can do. And that'll be the first part. The execution of this is far more involved and expensive than the execution of just looking out the window and seeing where the fucking sun is.
Yeah.
but
How do you
there's
get access
no
to the
correlation to the
ILS?
ground. Yeah.
So how do you get access to the ILS and get permission for the plane to do those that type of maneuvering in the vicinity of an airport? Do you have
you
this?
if you rent a plane, you can get the access. We propose a higher altitude than the normal landing. Then it's easier to circle there. Then they allow that.
So in other words, you're not on the flight path, you're above the flight path is how you're proposing this.
Above usual flight
Okay.
paths. Yeah.
And I'll just reserve the rest. So quick question. So the distance that we're going over the ground, you're using GPS for that, right? Is what you're saying? So where your point is, right? Using GPS in the plane, you see the signal, you're pushing the button to mark that waypoint. That's telling you what your Latin long is and altitude, right? So now you have two legs of the triangle to the transmitter, or to whatever point is on whatever point they're making that as the distance, correct? Meaning you have the GPS of the transmitter, you have the GPS in a plane. As it flies, it gets the signal. You push a button to set a waypoint. Now you have Latin long of both points and your altitude. So you have two legs of your triangle, correct?
You mean the hypotenuse and
no, you have the ground location, not the hypotenuse.
Yes.
You're going to have to compute the hypotenuse.
Yes, but
So-
you were referring to two straight or two angles, or what did you say?
So
we have those.
as you're flying in and you receive the signal on the GPS unit, you hit the button to set a waypoint, right? The pilot does. As soon as he hears that ILS signal, he hits a button for a waypoint, correct?
You hit the button before we want to see when the glide scope is activated and at our height.
Right. So when you receive it, you have to mark that point using, I'm guessing, a GPS receiver, where you have to set a waypoint that says, I received it at this thing. This because the plane's going to keep moving, right? So you have to set a waypoint. So the time it takes for them to push the waypoint, now that sets your your location in 3D space, right? Then you have the GPS coordinates of the tower, of the transmitter, right? So now you can figure out I'm at this altitude and here's the distance from my waypoint to the tower. Correct? So is that waypoint, according to this, going to be the hypotenuse or the adjacent angle? Or the adjacent leg? Is it going to be the leg over the Earth, or is it going to be the hypotenuse to that based off of what GPS provides you?
I lost you at some point, but I will try to. But I also have a more advanced setup where you also can calculate. It's not only this one waypoint, but you see that the distance, the change is important. But we are very much into details now already. What I was thinking is on Saturday, I would have
Okay.
like to present this on Saturday. We have not
So
even
I have-
done an experiment for the part, and for my experiment, we are already at the experiment part, and then the globe, we are only at the observation part. So it's not. Don't worry. I will think about your objections.
I'm just
So I
trying to
have a-
figure out how
I
we're
have a-
measuring things. That's all. Like we have to know the methodology, right? Because we can just
we
propose
can
all sorts of
replicate it.
ideas, but if you don't have some sort of methodology to answer the questions and be able to speak intelligently about it, you can't create a hypothesis that's going to be not vague.
We have the glide scope array. We have the primary flight display with this exact thing which shows the angle and the distances GPS. But I think about if we can do something else than GPS. But that's why I said I will think about it.
So I have a question. What is the margin of error this type of measurement? You've done that, right?
I said sometimes they say that these waves they interfere and make another thing, but then
It's called a secondary array, right?
yeah, this secondary array, but this is far out of our what we observe. Then it would be double the size at least of double the angle, and we are.
If
far
you want
out
to do
of
a
this
radio
margin.
experiment, there are far easier ways to do this that doesn't include the cost and the use of a plane with an ILS rated pilot. Because no offense, Kevin, you have a pilot that's willing to do this, but you're in Austria. I'm here in New York. Mike is in the Midwest.
Yeah,
Dr. Shiva's here in Boston.
You film the primary flight display. You film outside the window, and no, I don't think any AI will fake. I can go in there and film myself. If
No,
you think the AI will
I
fake
understand.
myself,
I understand the visual evidence, but what I'm
We're
getting
not
at
concerned about
is,
that.
Mike, you want to go ahead and jump in, Mike? I've been talking too much. Go ahead.
Yeah. I'm not concerned about anybody trying to fake it, because if anybody tries
No, I'm
to
thinking of
fake it, that's
cost
easy to-
and resources.
No. I'm directly addressing Kevin's thing, talking about AI faking things. Like, I'm not concerned about that, because any fakery, people can go test to see if it was faked themselves and then expose anybody that tries to do fakery. So my question wasn't answered though. What is the margin of error of this type of thing? Because if the your diagram there showed a difference of 1.1 nautical mile. If the margin of error is going to give us a greater than 1.1 nautical mile variation, then we don't have a measurement that can distinguish between the two predictions.
okay, I present it on Saturday. I don't know but I read today that it's far out of reach, and that's why I was glad with that. But I will give you the details on Saturday. But I'm sure it's way accurate, this the ILS tower, but I don't have the numbers now.
I mean, you can do a terrestrial radio experiment for line of sight using a civilian band in the 432 megahertz, which is an open channel, at least in the US. I'd have to check, see if it is in Europe. And you can do a line of sight for that and take into consideration things like beam divergence, refraction, and stuff like that we're all going to have to account for. And from there, we can create a model and stuff like that without having to use a plane and the costs and everything else. You can do it terrestrially on the ground.
Which instrument did you say?
You can use just a radio with a directional antenna and a receiver. So you can use handheld radios basically that can use like 432 megahertz, which is in the UHF band, which is line of sight, which we should be able to model.
Moving reference is still more telling than a stationary. Yeah, you can move this one as well.
Right. I mean, but even if you want to use a boat, right? Chartering a boat would be a hell of a lot less than chartering a plane. If you want to take a boat to go out in the water.
Yeah, it's close above water, and we had a lot of debates about refraction above water, and all the globe proponents say go above ground, go above ground. That's actually why this came up, that we can measure something high above ground. But I will think about your margin of error, and I like to go on with the method, or what else you would like to say, because I didn't prepare actually much today, because I thought I was hoping that I could present something. It looked like you only want to make it about the sun.
So, you had mentioned yesterday something about a 50-kilometer. Was this what you're talking about? Because this isn't 50. It was something else.
50?
Yeah, because you brought up
Yeah,
an observation.
you mentioned, yeah, some 50
No,
kilometer
I said, because you said instead of the sun, use something on the ground. I was just making up a number.
Oh, okay.
Look at something 50 kilometers away.
Yeah, I thought you had mentioned something about seeing too far. But okay.
Yeah, but I think to get out of refraction or to minimize refraction, we are fine with this one. Special importance is here the water part. You have an airport which is above water, but there are many.
All right, listen, we want to do science. We don't want to do bullshit where you can't actually do the experiment and then you can't execute it. One of the goals here is to make sure, as we said at the outset, that frankly, any citizen can go do these experiments. I think it's quite cost prohibitive to have any citizen go rent a plane, do all this stuff. So that's one of the weaknesses of this. If there's a way that Dan, perhaps you and Kevin can talk offline, that you can do this with some other ways, because the goal is to make this citizen science, that anyone can do this. This is not so esoteric. So I would say,
but simplicity is not everything. It's also not always necessary. We agreed with Toon that you if you not fake it, if you have visual evidence, it can be accessed by a lot of people. It's not,
right,
people
but evidence is reproducible predictions, Kevin. You have to be
it's reproducible. It's reproducible. People can
but I'm
come
saying-
visit. People can come join, and it reproduce it.
Right, but
it's $500.
Okay.
$500. It's not.
Right. So have you ever written the scientific method section of a paper?
Of which paper?
Have you ever written the method section of a scientific paper in your life?
I wrote.
Method section has to be very precise. It says
Yeah.
step 1, step 2, step 3, that anyone can pick it up and they can follow it. And if you can't
Yeah.
do that, it becomes bullshit. And I frankly don't want to participate in anything with people who are trying to, because look, I'm putting my reputation out there. A lot of people at MIT, why are you dealing with these flat earth people and these round earth, the debate's nonsense. So if I'm going to put my ass out there, which is what I'm doing, out of frankly a public service, I want to make sure that if you're going to propose an experiment, that the method section is something that can be executed as a recipe, like you would say if you're going to make a souffle. You do this, and you do this, and you do this, and you do this, and everyone gets the same souffle. You follow what I'm saying? And
Yes,
so,
yes, I wrote thesis. I'm in German. I'm sometimes in speaking not that well, but I can manage this. Yeah.
right. But I'm saying it has to be executable. So if we want to do that, because I think the flat earth people are always, from what I've seen when I was attacked, even this, get very vicious because they think the whole world is against them. And if you want to do that, great. But I really suggest that you make the method section very clear that that anyone can take it and execute it. And the formulae from both teams should be clear. So you can run it, you can plug it in, and you get data. So I think the input, as Dr. Prabhakar said, the input variables, the dependent and independent variables need to be clearly identified. And if we do that, I'm willing to participate in this effort, but if it isn't, it's just garbage science. And I'm not going to put my ass out there when I've spent most of my time trying to do good science with people who are basically dilettantes of making shit up. And I think that's the whole thing here, right? I had to talk with Ryan yesterday on this. Ryan was trying to understand what a formula is and derivation. So I think we want to make sure what emerges out of this is people actually know how to apply the scientific method.
So
And
I'm
I
sorry, I
think
didn't mean to
it's
cut you off. Go ahead, Doc.
Go ahead, Dan.
I was going to say, Dr. Shiva, maybe the best bet is to have the two sides work on putting together, for sake of another word, a scientific presentation to go over the methodology and everything else. It doesn't have to be, it has to be written out for a scientific paper, from the get-go, but at least, outline the variables, outline the individual,
Yes.
all the methodology and everything else, and present that on Saturday so we have multiple things to choose from. Because what I see happening is we can get to Saturday and let's say we all pick this one, right? We decide to do this. And we show up on Saturday and we present it and we're asking all these questions about methodology and everything else. And it basically turns into, well, the Globers are all punching holes in this because they don't want to do it, as opposed, and I'm not saying that's what's going to happen. I'm trying to think ahead here. If one experiment is vague and it gets presented and it gets, holes punched into it and it's not able to be resuscitated
Yes.
Get
here,
off the ground.
I
then
hear
we have other
projection.
ones
I
to
hear
choose from,
projection
is what I'm
already.
getting at.
I haven't heard about an experiment. I'm at the sun. We are still already at the observation part.
No, we're not.
So
So the experiment is quite simple, Kevin.
let go on, because yesterday when I asked for it, you
Well,
said
I mean, this is something,
first-
it was obvious, it was inherent in the presentation. Maybe you missed it. But if you have a
said
person here,
observation first, yeah.
well, if you have a person here at X1, Y1 date and time. So let's take the guy at the bottom right, and the Earth is flat. He's looking out his window and he sees the sun in X2, Y2. You understand that? He's looking out his window, a certain height and a certain location. So we should be able to, the flat earthers, and you can do this. You can choose a point. We can say we're all going to look outside my window, okay, at 8 a.m. on November 8th, okay, whatever location. And the formula here, the flat earthers should develop a formula, f of x1, y1, d comma t, and this should give, whatever the formula that gives, where is x2 comma y2. Does that make sense? And similarly, the globe earthers are going to have their formula up here, which will be for the globe function. Okay.
What time frame are you talking about? Like only this
that's-
point of time, sunset or
Anytime, D and T, date and time. You take a particular date and time, the location of this person, longitude and latitude, and you should be able to have a formula which calculates the sun. Very simple. I mean, the formulation will be quite complicated, but very simple to do. A child could do this once you have this formula. So, Dan, to your point, I think on Saturday, the globe earthers should define if the Earth is round, what are their independent variables. They don't have to present the formula. If they have it, great. And the flat earthers do the same thing. Similarly, going back to Kevin's thing, Kevin, you had the airplane here or the tower here. airplane here, we should get two formulas. Okay? So I think that's what we focus on. So you do have a ground point, which is a human being, just like you have the whatever your
The transmitter, right?
the transmitter. So it's the same thing. You see? So in many ways, you have two different things. This one, you have to be able to predict the location of. Now, believe it or not, I believe you could go to you could even use Grok or ChatGPT or Gemini for people who don't know math to calculate this. It will calculate this for you, and you could put in different locations of my location in Boston at a date and time. It should tell you where the sun is, and I should be able to look out my window and see where the sun is. You see what I'm saying?
Yeah,
So this
but
is
you don't know you assume a height of the sun. So my experiment already have an advantage. You don't have this height definitive number.
You don't have a height for flat Earth?
You don't have a height for the sun. Like we
Over flat
we
Earth.
could easier achieve this height for the plane because it's accessible, the plane.
So,
But
so
but it's
I just want to clarify. You don't know how high the sun is above flat Earth?
this is in question. It's not only about flat Earth. I don't know if it's
It should-
definitive above the globe. You assume this height
No,
on the globe.
I can address the globe. I'll talk about the globe. I'm just curious to you. You don't know how high the sun is above flat Earth? And you should. You're here on a science panel representing flat Earth. You should have a pretty good idea how high the sun is above flat Earth.
I'm still talking methodology. I thought it's not the debate part yet.
No, it's not
it's not a
a
debate.
debate.
wait.
No.
I just want to let you know. Let me finish. This is. Does everyone understand? This is almost akin to what Kevin you presented. Okay, and I just
Yeah.
did this very quickly. It's pretty rudimentary. Okay, so both parties should be able to develop a formula like this, which will predict, and the predictions you're looking out your window could, if you want, put it over, the ocean, and you're looking out the azimuth and the altitude, and you should be able to. You're saying where the sun is in your eye view. Does that make sense? It's pretty straightforward. Okay. Now, similarly, I don't have your diagram, Kevin, but you're gonna have a diagram which will predict the distance you're predicting this distance. We're predicting this location. You're predicting this distance in another formula. So I think to Dan, your point, and I think everyone, is in concurrence, on Saturday, people should come with these formulae, or at least the dependent and independent variables. And it's probably going to take them a week, depending on the math skills, to derive these equations. Whatever that is.
But yeah, just have a
But we're giving
methodology.
people a week,
that's,
not, my original goal was, I really wanted to put everyone on the hot seat, get up on a whiteboard, you claim you know math, derive it. And again, I think to Mike's standpoint, there's always been this saying, whenever you make things definitive, it appears the flat earthers always try to weasel their way out in some slimy way. And we want to stop that. Let's be definitive, not slimy, because I think it's very, very important for young people, others. We really teach people science. Yes, there are conspiracies. Yes, there are people who are fucking us over, but let's find out what are real conspiracies, what are fake conspiracies. So you have to be definitive. So I think what we're doing basically, I think, is we're, in fairness to both parties, we're going to have this experiment. We're saying two. I wanted to do one, so shitload more work, time. We're going to do two experiments, one of Kevin's proposal and one of the sun model here. So if you guys are in with it,
So it's
then
only
we're really-
distance and your angle, and this is which tool is, it doesn't matter. It's only the math first. Yeah, and not even on Saturday. Maybe, or if we have it on Saturday. Yeah.
Say that again, Kevin.
I was curious if you invoke a tool to look for the angle or something, or
Well, this formula, you just like you would develop, you'd say, here are my assumptions, and here's my result, right? Your formula you would develop.
And sun size is not not in question, and about sun distance or
You can, that's your, whatever you want to use.
Okay.
You make your assumptions. Imagine you're just doing a financial spreadsheet. You make, these are my assumptions, da, 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 and here's my formula. So I think, does that make sense? I think on Saturday, people should at least have their assumptions. Dan, is that what you're saying?
Yeah, you should have the assumptions, and you should have like the methodology, like how are you going to gather this information? Because I think the idea is it doesn't have to be exact, but at least have a framework in mind that says,
Yeah, okay.
you know, we're going to use a GPS for identifying locations. We're going to be, you know, just a framework, at least of the methodology of what's going to be measured and how it's going to be measured, and what as well as the variables, but like what kind of equipment are we going to need? What's the cost going to be associated with these? These are things that should come into this, because before we decide we're going to do something, we need to know what's going to cost the people, so we know whether or not it's worthwhile to put it out to the general public, or whether or not it's something that should be done differently.
All right. So Dan, you're saying that on Saturday, if the globe earthers want to take this and the flat earthers want to take the plane, for example, or you could switch it, doesn't matter. You should come up with the methodology, the assumptions for the equations. And the flat earthers should do that for this too. And then the globe earthers, the flat earthers should come up with the methodology for running their plane experiment. And then both flat and globe earthers should come up with the equations. We can do that there.
Right. And then Saturday, we can review them, and we can sit there and identify any shortcomings of either one of them that needs to be addressed.
Right. Because the goal is, what we leave is with a document which says we're all agreeing to this methodology, you know, and it's a work in progress, right? So we'll have a first draft of a document of 2 experiments, their methodologies, and areas that we don't agree to or agree to. Does that make sense?
Yep.
So you have to refine it on the next Saturday. But what
Since we're
you,
talking about the assumptions, I just wanted to bring in the GPS system is based on the principles that the Earth is a globe. So
The
just a
Haversine
heads
formula,
up.
correct.
right. So you have an iterative problem there. So the GPS system, Kevin, is already based on the fact that the Earth is a globe. So you have a bias right there. So if the Earth is a globe, and then you're saying we're going to use a GPS system, then you're going to obviously get the wrong answer in the flat Earth case. And then or you're going to get the inconsistent answer. And therefore, I think Dan comes back to your point, it's going to be inconclusive.
Well, and ultimately, if they do a coordinate transformation, they could figure out and calculate what the distance would be on a flat Earth and not use the Haversine formula, but they would be responsible for that part of it.
Okay. That's what Prabhakar is saying. So that's an example, right? When they're doing their measurement, you have to do the spherical coordinate, whatever transformation, you know? You have to flatten it.
Yeah, the polar distance formula would be.
Yeah, the polar distance formula. Yep. All right. So look, I think this is good. I think the devil's going to be in the details. And I hope everyone is collegial here. I think we all want to, frankly, do the math and educate people that these are tough problems. You can't just sort of hand wave, and you can't bullshit. I mean, if you took a dynamics class or a really good class in science and engineering, every word, every variable, every definition has to be precise. You can't just make shit up. And I think this will help the audience. This is not politics, you know, this is not grifting. This is engineering and science. And so that's where we may have to iterate a bunch of times, and there may be hard questions we're going to ask people. Like Prabhakar, you just bringing that up, you know? So you have to have a solution for that. Okay. All right. So I think, what time do we have, Prabhakar? That we start on Saturday?
11 a.m. I thought.
11 a.m. Okay, that's EST. And I think we have it going until 2, right?
3 p.m. I think.
Yeah, I think 3 p.m. Yeah. So we can take a short break. It will be recorded. And so I think when we start, we'll start with the scientific method. Prabhakar, if you can sort of I think we'll introduce people. What is the issue with people's privacy issue? I know we have people's names. Heather has put together a little poster of everyone's picture and everything that she's going to pop up. Everyone's cool with that, right?
Yep.
Picture and
Yeah.
name. Okay.
I mean, I'm on camera on my channel, so I mean, everyone knows.
Yeah,
who
but
I
we
am.
just want to make sure we're not going to put people's phone numbers or email addresses. That's internal. Okay. I think Bobby, is he still here? He wanted to know, Bobby, you wanted to know the other two people, Ryan.
He's not here.
No, he's still here over here. I see him.
He's
Bobby, are you there?
he's not on screen.
I'm here.
Bobby, you wanted the other two people, so Ryan and Kevin. If you want to send your contact, I think Dr. Prabhakar's host, he could then send it over to Bobby. Bobby, you want their email and phone or just their email?
Just email's fine.
Okay. So,
In the chat.
yeah. So that way, and I think everyone, so it looks like it's going to be 3-on-3. I'm going to get rid of, because the flat earthers, we're going to fix it, don't have enough people. So I don't want it to be 5-on-3. So I'm going to tell 2 of the people not to come. Okay. Be 3-on-3. You guys okay with that?
Yes.
Sure, or whatever. I'm okay with
All
it.
right.
Kevin, can you also send me your email? I'll share that with Bobby. And Bobby, if you can send me your email.
So we'll start with the introductions. We'll go over the scientific method. Then we'll start with, we'll say these are the 2 proposals, and we'll go through the sun, the methodology, and then we'll go to the airplane, and then the methodology, proposed methodology there. Does that sound good?
Yes, yes. And sorry,
then
guys,
we'll-
I'm tired. I'm tired. GPS isn't involved. I'm tired. Because the radio wave expert was saying GPS. It's the ILS. It's all about the radio wave, which gives the distance. I was bamboozled there.
All right, but anyway, all the details we'll figure out. Prabhakar, I believe if we tape this, we'll get a transcript to use to create the document, right?
Yeah.
So we don't need to have Heather there writing everything, right? So
Yeah, it can do the transcript. Yeah.
Okay.
Poor Heather.
All right. And then we'll create the document out of that. So what'll emerge out of Saturday is a document that has 2 experiments with hypothesis, methodology, and fill in here, fill in there, right? And then you come to next Saturday, it should be filled in. But we'll come up with is basically 2 experiments. Mike, are you okay with that, Ryan?
Yes.
Yeah.
Okay.
Yeah, I'm good.
Ryan?
Yes.
Bob? Okay.
Can you hear me?
All right. So everyone will be here.
Bobby.
Kevin, Ryan, Dan, Prabhakar, Mike.
Yeah, and
Okay.
just real quick, hey, Globe Slayer, it's nice to actually meet you for a change instead of just talking on X.
Is he there?
Yeah, I'm here. I'm here. Nice to meet you too. Sorry, I've been driving this whole time.
No,
I
that's
just
all right.
found out about this at the last minute, so I didn't get to really put any input, but I'll try to have some more time available Saturday.
Bobby, did you get my email and were you able to share your email?
Yeah, I didn't get his yet.
But are you guys interested if we do this? We could convert this to a scientific paper. I've looked at some education journals we could publish this in, but sort of high quality peer reviewed journals.
Sure.
That'd be great.
Everyone here would be,
Yeah.
authors of it. That's why I'm saying the methodology section should be tight, so people don't say this is a bunch of crap, because people just say this is stupid people writing shit. So it's got to be precise. So if you guys are open to that, we could get, we do this, and then the proposed experiment would be a publication. Results would be a follow-up publication. That could be a way to put this out there in a much more scientific framework.
I could definitely use it for my annual review.
Oh, okay. Yeah, I mean, publications take a while to do, but you just have to find the right journal.
Oh no, I know. I was just making an aside.
Yeah, but I'm saying I think this would be a tangible outcome. I think a white paper should come out of it for the initial piece, and then we do a follow-up. Does that make sense?
Yeah.
Okay. All right, everyone. See you guys on Saturday. Prabhakar, I don't know if you want to take a screenshot of what I just put up here. And Kevin, if you put a screenshot of that one slide 11, Dr. Prabhakar can include
Yeah, I
it.
have Kevin's
Okay.
screenshot.
You may just want to take one of this, Prabhakar.
Mhm.
Okay. All right. Thank you, everyone. We did it in 1 hour.
Hey.
Thanks.
Perfect. Yeah,
Thank you.
I need to go.
Bye-bye.
All right. Thanks, Doc.
Have a good
Bye.
day.
Okay, be well. Bye-bye.
See you.